Good afternoon, good morning, whichever time you're watching this video clip. We will look at production in the short run, the law of diminishing returns. Production in the short run is subject to diminishing returns. You may well have heard of the law of diminishing returns. It is one of the most famous of our laws of economics. To illustrate how this law underlies short-run production, let us take the simplest possible case where there are just two factors, one fixed and what? One variable. Here the case of a firm. Sorry, the case of a farm, I should say. Assume the fixed factor is the land and the variable factor is what? Labor. Since the land is fixed in supply, output per period of time can be increased only by increasing the amount of workers employed. But imagine what would happen as more and more workers crowded on a fixed area of land. The land cannot go on yielding more and more output indefinitely. After a point, the addition to output from extra worker will begin to what? Diminish. We can now see the law of diminishing returns. The law of diminishing marginal returns when increasing amounts of a variable factor are used with a given amount of a fixed factor, there will come a point when each extra unit of the variable factor will produce less extra output than the what? Previous unit. Alright? More you add, more people are work on the property. After a while, the amount of extra work, the output from each extra worker will begin to diminish because you have more people for work. Now get less work from them being done. That's all it is saying. Alright? We'll look at now the short run production function. Let us now see how the law of diminishing returns affects total production of our total physical product. Otherwise called, or sometimes it is called. Total physical product is the total output of a product per what? Period of time that is obtained from a what? Given amount of inputs. Well, again, the total physical product is the total output of a product per period of time that is obtained from a what? Given amount of what? Inputs. The product you get, the amount of output you get of a particular product based on the amount of things you put into it, basically. The relationship between inputs and output is shown in a production function. The production function is seen as a mathematical relationship between the output of a good and the inputs used to produce it. It shows how output will be affected by changes in the quantity of one or more of the inputs. Alright, go again. The production function is seen as the mathematical relationship between the output of a good and the inputs used to produce it. It shows how output will be what? Affected by changes in the quantity of one or more of the what? Inputs. In the simple case of the farm, with only two factors, namely a fixed supply of land, which is marked by Ln, and the variable supply of farm, which is marked by what? Lb, and Ln mean what? Land, Lb mean what? Labor. The production function would be TPP equal F, the function of land, comma, Lb. This states that total physical product, that is the output of the firm, over a given period of time is a function of, meaning it depends on the quantity of land and labor employed. You could express the precise relationship using an what? An equation as well. Go again. So this states that the total physical product, that is the output of a farm, over a given period of time is what? The function of that is it that is the total physical product depends on the what? Quantity of land and labor employed. You could express the precise relationship using an equation. The, as follows: the total physical product of a variable factor, for example, fertilizer, can be expressed as an equation. For example, TPP equal 100 plus 32 QF plus 100, sorry, plus 10 QF squared minus QF3. In this case, where TPP is the output of grain in tons per hectare, and QF is the what? Quantity of fertilizer applied in kilograms per hectare. Alright? So that would be a situation where that could be used. Alright? Alternatively, the production function would be expressed in the form of a table or what? Graph. Table 5.1 and figure 5.1 show a hypothetical production of a farm for a farm. Note the word hypothetical, please. Producing wheat. The first two columns of table 5.1 and the top diagram in figure 5.1, as you will see, show how total wheat output per year varies as extra workers are what? Employed on a what? Fixed amount of land. Now, let's look at this carefully now. Here you have this. I could actually pause the video and write this down so I'm going through the explanation. You'll understand. Alright? Good? Alright, so I want you to look at something carefully. That these different points, for example, point A. Point A is really between 2 and 3. Alright? Good? Just saying that to you. C is at 4. Point D is between what? What between what? 6 and 7. Alright? So look at that carefully, please. Good? Alright. So just note that, alright? Then you can look at the graph as well. And our focus on this line is on the what? Top graph. So you could pause the video and draw a top graph as well. We're gonna explain how this works right now. Pause the video, draw the graph. Top graph first. Alright. You can draw both graphs still anyways if you want to. So let's go. With nobody working on the land, output will be at what? 0, which is point A. Let's go again. Let's go back up here now. Right here, right? This is point A. Good. So this line is it what? Total physical product line. Alright. Good. At the first As the first farm worker are taken on, wheat output will what? Will initially rise more and more rapidly. Alright? The assumption behind this is that with only 1 or 2 workers, efficiency is what? Low. Since the workers are what? Spread to what? Thinly. With more workers, however, they can work together. Each perhaps doing what? Some specialist job, and thus they can use the land more what? Efficiently. Look at this now. At at no workers there is what? Zero production, zero output. When you have 1 worker, you end up with what? three what? Three um what's called it now? Three stocks of wheat or three. Let me go again. It would have been 3 kilograms of wheat, so to speak. When you have two workers now, you end up with what? 10 for total physical product. So when you have three, you end up with what? 24 for total physical product. Alright? So as you go along, it what? The amount of production that goes in increases. That's the important thing here to note. Alright? Good. In table 5.1, output rises more and more rapidly up to the point of the what? Third worker, which is at point B. Let's go back up, which is about between 2 and 3 right here. So you realize that from 2 to 3 it ended up with 14, increase of 14, right? Here right at that. And in this case is at what? Point B right here. Between 2 and 3, alright? Now in figure 5.1, the TPP curve gets steeper up to what? Point B as well. After point B, however, diminishing marginal returns set in. Output rises what? Less and less rapidly, and the TPP curve correspondingly becomes what? Less steeply sloped. Let me show you something now. Notice that after 24 you get what? Addition will give you 12, then 4, then 2, then none. Then you end up with a situation where you start going down production wise. Can you move from 5 to the 5? That means you're reducing, right? Okay. As you see right here, the steep going right up, but now it start go down after a while. Alright. So the point B, over diminishing return, my return setting, output rises less and less rapidly. The TPP curve correspondingly becomes less steeply sloped. Alright. We soon look at the other parts of the table, APP and MPP. Now when point D is reached, wheat output as at a maximum. The land is what? Yielding as much as it what? Can. Any more workers employed after that are likely to get in each other's way. Thus beyond point D, output is what? Likely to fall again. 8 workers produce what? Less than what? 7 workers. And we still look at point D now. Right here. Point D is really between 6 and 7 as shown on the graph right here. So this is the amount, this is maximum amount that can be produced by what? 7 workers, 6, 7 workers. Okay? After that now, you start going down. 8 workers produce less, and you will see that 8 workers produce what? Less than what? 7 workers. 8 workers produce a total physical product of 40 compared to what? 7. For remember that remember that 7 is what? Number of workers, right? Good. Remember that, folks. Let's look at something slightly different now. The short-term production function, look at average and what? Marginal product. Alright. So a while ago we looked at total product and numbers of workers. Good. Before I go any further, all right, never mind. Let's continue. In addition to total physical product, two other important concepts are illustrated by a production function, namely average physical product and what? Marginal physical product. Average physical product now, this is output per unit of the variable factor. In the case of a farm, it is the output of wheat per worker, which would be calculated as total physical product divided by what? Quantity. Good? Alright, let's look at it now. Now, thus in table 5.1, the average physical product of labor when four workers are employed is 36 divided by 4, which is equal to what? 9 tons. Now, remember that QV is what? Variable quantity is variable factor. And the variable factor in this case is what? Labor. Good? So that's how you get it. So let's walk up a little bit. If you have written out then go back up, I don't show. So between the average physical product for when there's four workers is 36 divided by 4 give you what? 9. Alright? So that would give you an idea now. So the average physical product when there's one worker is what? 3 divided by 1 which give you 3. The average physical product for when there's two workers is what? 10 divided by 2 give you 5 and so on and so forth. Alright? So that's how you calculate average physical product, which is what? Total physical product divided by what? Divided by the number of the quantity of variable factor. Alright? Which in this case is the number of workers. Alright? Let's continue. Marginal physical product now. This is the extra unit, extra output, otherwise called change in total physical product produced by employing one or more unit of variable factor. Thus, in table 5.1, thus in table 5.1, the marginal physical product of the fourth worker is 12 tons. Go again. Marginal physical product is what? Is the extra output. Is the extra output or change in physical product produced by employing one or more unit of the variable what? Factor. Remember this case of the variable factor is what? Labor. Thus in table 5.1, the marginal physical product of the fourth worker is 12 tons. The reason is that by employing the fourth worker, wheat output has risen from tons of 36 tons, sorry, from tons to 36 tons. A rise of what? 12 tons. Let me go again. Should be from 24 tons. My apologies. Let me go again. So them go again. So this is the extra you output, which is changing total production, changing total physical production. Remember the diagram, this symbol here mean what? Change in, right? Change in total physical product produced by employing one or more unit of variable factor. So in table 5.1, the marginal physical product of the fourth worker is what? 12 tons. The reason is that by employing the fourth worker, wheat output has risen from what? 24 tons to what? 36 tons. A rise of what? 12 tons. In symbols, the marginal physical product is given by MPP equal change in TPP divided by change in what quantity. Remember, I said there is additional 12 tons and there's only what? One worker. This is what, so the variable factor is what? 1 in this case. As compared to the what? The total physical product. So you have 12 divided by what? 1. Alright? So the marginal physical product then for this person is what? 0. The marginal physical product is 3 here. Why? Because 3 divided by 1 give you what? 3. 0 to 3. When you reach 2 now, 3 to what? 3 to 10 is what? 7. And 1 to 2 is what? 1. So there's a change of 1 here for the variable factor, which is quantity, QV. Alright? A quantity of variable factor. You divide the 7 by 1, you get what? 7. And so on. So there's a change in the physical product. You divide by what? Change in the variable factor. That gives you what? Your marginal physical product. Alright? The reason why we divide the increase in output by the increase in quantity of the variable factor is that some variable factors can be increased only in multiple units. Note that in table 5.1, the figures of MPP are entered in the spaces between the other figures. Alright? Go again. Just remind you that. So note that in table 5.1, which is this one, this table right here, the figures for MEP are supposed to be entered in the what? In the middle. So right. 3 is supposed to be between what? 0 and 3. 7 between 3 and what? 5 by right. 14 between 5 and 8. 12 between 8 and 9. 4 between sorry. 3 between 1 and 2. My apologies and the folks. My apologies again. 3 should be between 0 and 1. 7 between 1 and 2. 14 between 2 and 3. Sorry. 12 between 3 and 4. 4 between 4 and 5. Yeah. 2 between 5 and 6. 0 between 6 and 7. And negative 2 between what? 7 and 8. That's how it should be written by right. Alright? But because of the fact I cannot do it like that in this case this is structured, that's why I see it like this. Alright? So if you're writing it down, it will be between them, okay? Remember that, okay? Alright. So the reason is that MPP can be seen as a difference in the output between one level of input and another. Thus, in the table, the difference in output between 5 and 6, right here, so, is what? 2. It's 2 tons. Alright? The figures for APP and the MPP are plotted in the lower diagram, which is right here, good, of figure 5.1, which is this right here. We can draw a number of conclusions from these diagrams, but I won't go into these details. So this is MPP, APP, and so forth. Alright. One of them would be, let me, if I go any further, so we can draw a few conclusions from here. A few conclusions include one of them. One conclusion is that the MPP between 2 points, which is the marginal physical product between 2 points, is equal to the what? Slope of the TPP curve. The total physical product curve between what? Those 2 points. For example, when the number of workers increases from 1 to 2, which there indicates is a change in field labor of 1, TPP rises from what? 3 to 10. Right? It's from here to what? Here. 3 to what? 10, right? Both right there. So go. So from, let me look at it now. So from 3 to, so you say you have 3 here, so you go from 3 to 10. Alright? Which is a change in total physical product of what? 7. MPP is the 7, right? The slope is a line between the what? Points G and H, which is right here. Alright? MPP rises at first. The slope of the TPP curve gets what? Steeper. MPP reaches a maximum at point what? B, which is right here. So, at that point, the slope of the TPP curve is at its what? Steepest as well. Because notice that it start taper off, go straight up, it start go wider. After point B now, diminishing returns set in. MPP what? Falls, as you would see coming down here. Good. TPP becomes what? Less TP as well, as you see. APP rises at first, as you can see right here. It continues rising as long as the addition to output from the last worker is greater. Meaning, as long as marginal physical product is rising, it's greater than the average output, right? The MPP pulls the APP up. This continues beyond point B, as you see here, beyond this point right here. Even though MPP is now falling, the APP goes on rising as long as the MPP is still above what? The APP. Alright? Thus, APP goes on rising to what? Point C. Beyond point C, MPP is below APP. New workers add less to output than average. This pulls what? Average down as well. So it start go down. This put the average physical product down as it falls, right? The average, sorry, this pulls the average down and the APP curve falls. As long as MPP is greater than 0, TPP will go on rise. New workers add to total output. At point D, TPP is at a maximum. Its slope is what? 0. An additional, which is right here, right? An additional Worker will add nothing to output. MPP is what? 0. Beyond point D, TPP false. And MPP is negative as you saw on the table above. Thank you for watching. And very shortly, you will see another clip coming up. Please continue to exercise consistent viewership and make notes as you go along, gentle folks.